Hello, everyone. Today we're going to talk about average values and indicators of variation. So first of all, why do we need the average values and these indicators of variation? These parameters are useful in understanding the underlying trends of the data that we have on hand. So in other words, imagine that you have examined 7 patients. You've measured their blood pressure, and your results are depicted at the slide. So you have 7 patients, and all 7 have different blood pressure. And imagine that you need to tell someone what about blood pressure is in the population that you've studied. So one way to do it is to say that patient number 1 has something around 110, another one had 150, the third one had something like 120, and to enumerate all the patients. It is a good idea to do if you have very small number of patients or number of observations. But if the number of observations is big, it becomes pretty tedious process to do. And you would like to have some kind of shortcut to describe in 2 words what's happening with blood pressure in your studied population. So in this example, I've suggested the measurement of a mean or average value. It is described as a horizontal line. So it says that on average, people in the studied population had blood pressure of something around 140. So on average, blood pressure was 140. In some people it was less, in some people it was more. But as you can see, no one in the population had exactly the value of 140. Yeah, so mean or average value doesn't represent the exact value of a single person in a sample, but still it stands for the average value in the sample overall. So about which kinds of values can we use for description of general trends in the sample, we will talk today. So first of all, we will start with the measures of central tendency. So measures of central tendency are the instruments or numbers which allow us to describe what happens overall with the numeric parameters in the studied sample. We've discussed already something about mean or average value. There are also 2 instruments. They are median and mode. So a few words about each of them. Average value or mean, it is the sum of all observations in the studied population, which is divided by the number of observations. So how it is calculated? So M, usually it stands for mean in statistical literature. It is the sum of observations. This Greek symbol sigma stands for sum. So you need to add up all the numbers in a row. So and add up all the numbers and divide it by n, which is the number of observations. Average value is good and very useful for description of normally distributed data. So what is normally distributed data? So let's begin first of all speaking about distribution. Distribution is the term which refers to how frequently certain observations occur in a data set. So sounds a bit complicated, but if you will mark, for example, on X value, the values of blood pressure, possible values of blood pressure which exist in your study sample, and on Y-axis you will mark the frequency of how often each value occurs in your sample, you will see that they form some kind of shape, yeah? And in normally distributed data, the roughly same number of observations, first of all, is represented on both sides of the mean. So on the center of normal distribution, there will be a mean. In this case, it's described as a letter mu, is another way of the description of mean. So, and on both sides of this mean, there will be plus minus equal number of observation. Yeah, and these observations will be closely grouped closely to the mean value. So, and in this case, the shape of this distribution will resemble the shape of a bell. So this is how normal or parametric distribution look like. Why does it matter which kind of distribution do the data have? It matters because in case of normal distribution, mean, mode, and median usually coincide, and the data distribution has the shape of a bell. Actually, the shape of a bell is more for a visual representation, but the issue is that the type of data distribution will determine how well central tendencies describe it. So if you kind of noticed, mean, mode, and median can be more or less equally used for the description of normally distributed data because they usually stand close one to another. Yeah, but if the data is distributed non-normally or non-parametrically, or in other words, if the data is skewed, you can see that mean starts representing only small part of the population. Yeah, and you see that the distance between mode, median, and mean starts to increase. It actually might be a good instrument to assess the type of data distribution by calculating all three parameters and drawing conclusion from that. But for now, I would like to throw a caveat that mean can be used for description only normally distributed data. If the data is skewed, if data is not non-normally distributed, mean is not correct depictor of the general tendencies. So we should be aware of it and to be very cautious if you have doubts about the data distribution and if you see that the mean was chosen for representation of the central tendency. So the next value that I would like to talk about is median. Median is the value which stands in the middle of an ordered data set. So imagine that we have a data set. Let's say it might be kind of whatever. It might be, for example, for simplicity, the count of episodes of flu during the previous year in some population. So we have the same amount of people, 7 people. First one had 1 episode, the second one had 4 episodes, and so on and so forth. So mean, as we know already for calculation of mean, we need to add up all these numbers. We get 21 divided by 7, and we get 3. So on average, 3 episodes of flu. There were 3 episodes of flu in this studied sample. So how do we calculate median? Median is calculated, first of all, after the ordering of the row of numbers. So from the smallest to the largest. So we order it from 1 to 5. If we see repeated values, we just put them one after another. And then we select the one which is in the middle. So for the number of 7, the one is in the middle will be the 4th number. Yeah. So we select the 4th number. It is in the middle. So median is 3 as well. Median coincides with mean, which can tell us that probably the data is distributed normally. But for such small data sets, I would advise not to draw such strong conclusions about data distribution if the data is small. Usually we assume that if the data set is small, below 30 observations, usually it is assumed as a non-parametrically distributed data just because the number of observation is low, even if the shape of the distribution resembles the bell curve. So it's just small commentary. So, and now we are gonna look why does it matter what do we measure, mean or median? So imagine that in the existing data set, we've added up one person which has had 28 episodes of flu during the previous year. Yes, so you can see it's outstanding results. It is very different from what we've seen in the previous data set. Yes, so the number of observations has increased by 1. But after we calculate the mean value for this specific purpose, we can see that mean value has changed from 3 to 6.2. So with the addition of one extra person, which has had very large number of episodes of flu previously, the mean has increased in 2. So you can see that the presence of outlier distorts mean very drastically, multiplies it in this case by 2 and a bit more. But when we calculate the median in this case, so what do? We order the numbers from the lowest till the largest, and then we calculate median. So for calculation of median, for example, for this specific kind of data set, we need to select 2 in this case, numbers in the middle, because the overall number of observations is 8, and to find average among them. So we select those 2 in the middle, it will be 3 and 3. The average value for 3 plus 3 will be again 3, so median is 3. So you can see that addition of one very different observation to the sample did not influence median at all. Yeah, so or it will influence median in much less degree than it can influence mean. So this is this example should show you, should understand why median in some cases is better than mean. So because it's less sensible to these big numbers which may from time to time occur in the studied sample. These big numbers are called outliers. Yes, so outliers, these are the values which are very, very different from the general tendency of a of the sample, and which distort the general central tendencies. Yeah, I've seen one good example on YouTube video about mean and median. So they proposed the example. So imagine that you have a group of people which have a revenue, annual revenue of $20,000, yeah, and their mean will of revenue, annual revenue will be again $20,000, and median will be again $20,000. But if you will add up to this group of people one multimillionaire, the median will skyrocket. So it will, the mean value will become something around $9 million per person, while the income for the majority of the sample hasn't changed. And the median will show us exactly the correct value of annual income for everybody, even with the presence of this multimillionaire. So this is why you need to be, first of all, cautious about presence of outliers in your sample, and secondly, you need to calculate both mean and median, and ideally mode as well, to understand better your data. And the third one, just one moment, please. So the mode is the third variant of description of central tendency. It is the most frequent value in a data set. So we continue our work with our distorted. Mode can be also useful in case of distorted data. So once again, you can see that the mean has become very sensitive to the presence of an outlier, and median and mode has remained the same. So they are more beneficial in case of skewed distribution of data. So once again, in case of normal distribution, all is fine. Mode, median, mean, they tell us exactly the same information. But in case of skew, they become less useful in terms of representation of general tendency. So you can see that maybe in case of skew, mode may be the best option, but it's not always the case, because sometimes distribution might have more than one peak. Yeah, so for example, in this case, the distribution will become bimodal. Yeah, so in this case, you will have 2 or 3 modes, and it might be very tricky to get general idea just from numbers. I'm telling you this for understanding that there is no one recipe that fits all situations in terms of distribution of central tendency. Usually you would like to have on hands more mean, median, and mode, and desirably the visual representation of data to have an impression with what kind of data you are working with what kind of data you are working. And for the terminology, the skew, yeah, so you see that there might be right skew when the more steep side of the curve is kind of to the left and less steep is to the right. So this is the right skew. And there might be also left skew when the less steep skew will be to the left of the top of the distribution curve. So these were the measures of central tendency, and also we would need to discuss the measures of variation, and we will begin from the range. Range is a kind of simple value which tells us about the distance between the smallest and the largest values in the data set. Yes, so let's say we're working with the same data set. For the smallest value will be 1, the largest will be 28, and correspondingly the range will be the difference between these two numbers, which will be 27. So this is the distance. It will make 27 points from the smallest to the largest values in the data set. So this is about range. Similar thing to the range, it is limits. So limits are the borders which mark the smallest and the largest values in the data set. So you can see that limits in this case will be 1 and 28. So the smallest value is 1, the largest 28. So similar information to the range, but still it is different. So if it would be, for example, the smallest value would be 101 and the largest 128, the limits would be 101 and 128, but the range will be the same. So this is why it might have sense to specify limits and range separately. Also, often you might see such a parameter as the interquartile range. Yes, so basically interquartile range is the spread of the middle 50% of the data. So you split the data into 4 equal portions. You use for the operation only the middle 2 quarters, and the spread between these 2 middle quarters will make the interquartile range. Usually it is depicted as the 2 numbers in square brackets. Yes, so in our case, you need to put away the kind of the head and the tail of the data row, leaving only the core, and the smallest number in this core will be the lowest border of interquartile range, and the highest value will make the highest border of interquartile range. So in this case, the interquartile range will be 3 and 4 with the median of 3. So this is how you can see non-parametrically distributed data are described. Another one, and it is tricky, measure of variation is variance. Yeah, so for the simplicity, I will take the simplified version of our data set without an outlier, the data set of 7 observations with the mean value of 3. So the formula of variance is to calculate the variance, you need to calculate the average value, then to subtract this average value from each observation and in your data set, and to square it up and then to add it up. Yeah. So what do we do? So we know that already that the mean value for this data set is 3. So first of all, you need to subtract 1 from 3 and square it up. Then you need to subtract 4 from 3 and square it up. Then you need to subtract 2 from 3 and square it up, etc., 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 and you will get this sequence of numbers. So 3 minus 1 squared, it will be 2 squared, it is 4, so 4. Then 3 minus 4 is minus 1 squared, it will give you 1. So yes, here you have 1. 3 minus 3, it is 0. 0 squared is 0. So 4 plus 1 plus 0 plus 1 plus 0 plus 4 plus 0 gives you 10. So this is the variance. So variance is 10. If we're speaking about, if we say that this is a data set of the number of episodes of flu which occurred in the previous year, so in this case, the unit of measurement for this variance will be episodes squared. Yeah, so sounds a bit tricky. So to describe the general tendency, you will say the average value of episodes of flu in the given population was 3, and the variance of this number of episodes in the given sample was 10 episodes of flu squared. So I don't know actually what does it mean, episode of flu squared. So this is why variance is not a very good measure of representation of data spread. Yeah, but actually there are another reasons why variance might be not best option, but still it's useful as the intermediate step for calculation of other statistical parameters. So for this purpose, we calculate, for example, standard deviation. Yeah. So for this purpose, we just need to get a square root from variance. Yes. So standard deviation is square root from variance. We just get rid of this squared number of episode of flu from the previous year. So we repeat the same procedure, but in the end we get a square root of 10, and we get 3.2 episodes. Yeah. So what does it mean in the human language for us? So the average value of episodes of flu in the previous year in the given sample was 3. And there was fluctuation in this number of episodes from kind of 3 minus 3.2 from 0. Technically, this is what data tell us. And the largest value could happen to be more than 6. Yeah. So this value of standard deviation is kind of closer to real life in order to describe how far from mean data may deviate. So why else do we need standard deviation is because in normally distributed data, it allows us to prognose how many data can we expect to occur closely to the mean value. So what does it mean? There is a 3 sigma rule, and which tells us that within 3 sigmas, if the data is distributed normally, we expect to see 99.7% of observations. So even if there are outliers, only 0.3% of this data will fall out from the boundaries of 3 standard deviations from mean. Yeah. So you can calculate, you can take mean, add up 3 standard deviations to the up side, to the downside, set these boundaries, and expect that the majority of data will fall within these boundaries if the data is distributed normally. So this is why, this is one of the reasons why should we calculate the standard deviation. This is all for today's topic. Thank you for your attention. The final remark that I would like to make is that unfortunately, the data in biomedical sciences relatively rarely fall into criteria of parametric distribution. How to deal with the data which are distributed non-parametrically, we will speak in more detail about during our practical lessons. Thank you.